frequency, worked examples and practice sessions. There will be a quiz at the end to test your knowledge. Introduction to averages. Averages are single values that represent a set of data, providing a concise summary of its central tendency. They help us understand typical values within a dataset, making complex information more digestible and comparable. Different types of averages are suitable for different kinds of data and analytical goals. The three most common types of averages are the mode, median, and mean. Each offers a unique perspective on the data's central point. For instance, while the mean is sensitive to extreme values, the median provides a robust measure for skewed distributions, and the mode identifies the most frequent occurrence. Understanding discrete data. Discrete data consists of values that can only take on certain numerical values, often whole numbers, and are typically obtained by counting. These values are distinct and separate, meaning there are no intermediate values between them. For example, you can have 2 or 3 children, but not 2.5 children. Common examples of discrete data include the number of students in a class, the count of cars in a parking lot, or the number of heads when flipping a coin. Such data is fundamental in many statistical analyses, especially when dealing with countable events or items. In contrast, continuous data can take any value within a given range, like height or temperature. Frequency tables explained. A frequency table is a structured way to organize raw data by listing each distinct data value and the number of times it appears in a dataset. This organization makes it much easier to analyze and interpret large amounts of data, revealing patterns and distributions that might otherwise be hidden. It's particularly useful for discrete data. The table typically has 2 main columns, one for the data values, e.g. number of cars, and another for their corresponding frequencies, e.g. frequency. Sometimes, additional columns like cumulative frequency are added to facilitate further calculations, such as finding the median. This systematic arrangement is a cornerstone of descriptive statistics. Identifying the mode. The mode is the data value that appears most frequently in a dataset. It is the easiest average to identify, as it simply requires counting the occurrences of each value. A dataset can have one mode, unimodal, multiple modes, multimodal, or no mode if all values appear with the same frequency. It is crucial to remember that the mode is the actual data value itself, not the frequency count. For example, if 1 appears 16 times and 2 appears 12 times, the mode is 1, not 16. The mode is particularly useful for categorical or discrete data, where identifying the most popular or common item is important, such as the most frequently purchased product. Consider a frequency table showing the number of cars parked in the grounds of some buildings. The table lists the number of cars, data values, and their frequency, how many times each number of cars was observed. To find the mode, we simply look for the number of cars that has the highest frequency. In this specific dataset, the frequency of 16 corresponds to 1 car. Since 16 is the highest frequency, the mode is 1. This means that 1 car parked is the most common observation in this dataset. Introduction to median. The median is the middle value in a dataset when the data is arranged in order from smallest to largest. It is a robust measure of central tendency, meaning it is less affected by extreme outliers compared to the mean. For example, in a salary dataset, the median provides a more accurate representation of typical income than the mean if there are a few extremely high earners. To find the median, the first crucial step is always to order the data. If there is an odd number of data points, the median is the single middle value. If there is an even number of data points, the median is the average of the 2 middle values. This ensures that half the data points are below the median and half are above it. Cumulative frequency. When working with frequency tables, especially for larger datasets, calculating the median directly can be cumbersome. This is where cumulative frequency becomes invaluable. Cumulative frequency is the running total of frequencies, showing how many data points fall at or below a particular value. It essentially transforms the frequency distribution into an ordered list. To create a cumulative frequency column, you start with the first frequency and then add each subsequent frequency to the previous cumulative total. The final number in the cumulative frequency column should always equal the total frequency, n, of all data points. This column helps quickly locate the position of the median and other percentiles within the ordered dataset. Calculating median with cumulative frequency. Once the cumulative frequency column is established, finding the median becomes a straightforward process. The median's position in an ordered dataset is given by the formula n plus 1 by 2, where n represents the total frequency or the total number of data points. This formula tells us which position to look for in the ordered data. After calculating the median position, locate this position in the cumulative frequency column. The data value corresponding to the first cumulative frequency that is greater than or equal to the median position is your median. This method efficiently pinpoints the middle value without having to list out every single data point individually, which is especially helpful for large datasets. Median, cars data example. Let's revisit the cars park data to calculate the median. First, we need to add a cumulative frequency column to the table. The total frequency n for this dataset is 53. Using the median position formula, we get 53 plus 1 to 27. This means the median is the 27th data value. Now, we look at the cumulative frequency column. The first cumulative frequency that is 27 or greater is 33, which corresponds to 2 cars. Therefore, the median number of cars parked is 2. This indicates that when the data is ordered, the middle value is 2 cars, providing a central measure that is not skewed by any extreme counts. Worked example, children in families. Let's work through another example, the number of children in families. The frequency table shows the number of children and their frequency. To find the mode, we identify the number of children with the highest frequency. In this table, 11 is the highest frequency, corresponding to 1 child, so the mode is 1. For the median, we first add a cumulative frequency column. The total frequency n is 40. The median position is 40 plus 1 over 2 equals 20.5. Looking at the cumulative frequency, the 20.5th value falls within the 29 cumulative frequency, which corresponds to 2 children. Thus, the median number of children is 2. Practice, class attendance, mode. Now, let's practice with a new dataset. Class attendance. The table shows attendance data values and frequency, how many times each attendance number occurred. Your task is to identify the mode from this frequency table. Remember, the mode is the data value with the highest frequency. Carefully examine the frequency row and find the largest number. Then, identify the corresponding attendance value. This value will be the mode, representing the most common attendance figure for the class. This exercise reinforces your understanding of how to quickly pinpoint the mode in a given dataset. Practice, class attendance, median. Using the same class attendance data, your next task is to work out the median. First, you'll need to add a cumulative frequency column to the table. Calculate the total frequency n, and then use the median position formula, n plus 1 over 2. This will tell you which data value to look for. Once you have the median position, locate it within your cumulative frequency column. The attendance value, corresponding to the first cumulative frequency, that is greater than or equal to your median position is the median. This practice helps solidify your understanding of the full process for finding the median in a frequency table.
Summary. Well done. You have completed the course Discrete Data, Mode and Median in Frequency Tables. You should now be familiar with averages, discrete data, frequency tables.